Um, we're living in a hybrid environment. We're dealing with remote instruction. Elementary schools and high schools and all the secondary education, they're all, primary, secondary education are all, doing some sort of mixture of the two, of remote and in-person. Having online options is definitely going to be kind of like a bread and butter moving forward. So this is an option that you can kind of throw in your toolkit, because it's not just limited to calculators. It's also got activities and features built in that I can, I'm going to, like I said, I'm going to walk you through how to construct an activity. But for now, I'm just going to kind of acquaint you with it. So that if you had a thought when you're developing your activity for the Unit 1 assessment, if you're thinking about maybe doing something that has an online component, because I know as I was reading the ones that we're able to post on the discussion, it ranged. Some people are looking to do pre-K stuff, and some people are looking to do higher levels, so 3rd, 4th grade, and so on. So you just want to give you all the different options. So one thing that you could do, very simple, 4-function calculator, nothing too complicated. And it's kind of funny because they call it a 4-function calculator, but they give you more than 4 functions. So they're lying, but it's a good lie. They're giving you square roots and stuff like that. But if you have a website, or if your school is using, we're using Blackboard, but most schools have some variation of that, like IXL, things of that nature, then you might want to embed a calculator. And if you do that, it's very user-friendly, 9 times 9, that kind of thing. So very straightforward, clear all, just the way this kind of stuff works. But you could also set it up for a projector mode so that your students only see certain things. You could change the contrast if you want. So that's that. You can play around with that. It's free. That's the one benefit of it. There's many benefits of it, but that's the one. We want to start the conversation off with free, and then after that, we talk about all the wonderful features. I've been in enough trainings over the years where it's like, yeah, it does this, it does that. It's so wonderful. And oh, by the way, it's $100 a month. I'm like, well, why'd you just waste the last hour of my life? I'm not paying $100 a month, So scientific calculator, a little bit more advanced. It's got some powers, it's got some trig functions, not something you would need in an elementary school classroom. This is the reason why I'm bringing up scientific, is because it brings fractions into the party. Right. So if you want students, and this is one of the benefits of involving technology, if you want students to apply their learning, right? So they know how to, maybe they don't know, but you've assessed them on their math already. All right. Like you gave them an in-class assessment, a skills assessment, like the one that I'm going to give you on October 6th. You've already tested them on whether or not they can multiply fractions or subtract or add fractions, common denominators and all that stuff. You've already done that. Sometimes you want them to go beyond the curriculum, explore some real world phenomenon, collect information about the real world, and then along the way, they might have to evaluate it mathematically. So when they do that, you don't always want them to get bogged down by the math. You want them to start thinking about the analysis of the math. So a tool like this could be really useful, because if the goal of the assignment is not for them to be able to multiply fractions, but know what multiplied fractions the result actually means, then that's something that we could use this for. So let's say I wanted to take 2/3 and add to it 1/2. Right. I could also click on this little jammy here and it'll convert it over to fraction form. I can click it back to see the decimal form. So this is a really nice way if you're teaching a class, you you just ask the students to work on a problem. You just ask them very simply, you put it on the board, or maybe you gave them a worksheet. You just said, take 2/3 and add 1/2 to it. What do you get? All right, 7/6, but maybe you're converting back and forth. Maybe you're working on how to go back and forth between decimals and fractions. Then this is a nice, quick way of getting that conversion back and forth, and say, okay, it's kind of like a big reveal. All right, so what do you get when you convert 7/6 into decimal form? Did you do it right? Well, let's take a look. Boom, there it is. You know, so that's a nice little feature that you can kind of incorporate. It's just using, and it's not so much the calculator part of it. You're using the ability to display a calculator. All right, so, and it's free. So that's the important part, because when they get older, and the whole world tells them that they need a TI-80 whatever calculator, and it costs $100, and it takes a lot of the shine off of everything. But for now, it's like you can rely on free resources. So that's another aspect that you can kind of bring into the conversation. But you see down here where it says, are you using Desmos in a classroom? And you're just getting started with this, so you're like, I don't know, maybe I will, maybe I won't, depends on what you got, right? So if you browse activities, you're a teacher, so you're browsing activities, you have, like some pretty advanced stuff here, but you also can find some simpler things, right? So, just type in a concept that you're looking to investigate. So let me just say, I'll type in average. All right, so let's see what this one's all about. So I'll do the student preview. So it's just asking you, what do you notice from a graph? So, and in this case, it's like, I don't even know. It's like, well, clearly this is a science related concept, but it has some math involved in it, because it looks like there's different temperature zones, but it's just really asking you if you notice anything significant. And so you can start getting into an explanation. You can say, I notice different weather in different areas, depending on what these color schemes mean. Because it's talking about average first leaf appearance. Maybe we're talking about, green means like more leaves, or maybe specifically it's green leaves. I don't know, but it's, it's a little bit of an analysis piece, but it's all based off of a diagram. So you import a diagram, you ask a probing question, they put their thoughts and share it with the class, and then all the other responses for all the other students would show up there. And then you could have a nice conversation about it, all right? So then next, you look at the next slide. What do you wonder? What do you wonder from the graph? That's kind of like a new thing that I don't really like it, but like education goes through cycles when it comes to verbiage and buzzwords. Like wonder is now like a big word. They want to know, what do you wonder? I wonder this. It's just like, it just seems contrived, but that's kind of what they want you to say. They want you to use that kind of terminology. So what do you notice? What do you wonder? And write, in this case, write a catchy headline. That's the fun part of it. But, like if you think about something like this, I mean, you can give, really anything you can think of. You can create, let me go to the next one and see. Yeah, summary, comparisons from one to another. You can create little slides. It's kind of like interactive slides. Imagine a PowerPoint, but where the students can interact with each other and interact with you. But any image that you can think of, you want it to be math related specifically, but if you're talking about, I know somebody said that they were focusing on shapes. I read some of the discussions, so they're looking at shapes, and it's for the young ones. But if that's the case, then you could throw on a slide a bunch of different shapes, and it gives the options. You could do multiple choice. You can move them around and play and group them together. There's a lot of different possibilities. So That's just a small example. I mean, there's some pretty heavy duty stuff you can do in here too. You can make graphs, function graphs, do some high level mathematics with it, but that's not really what we need at this point. It's just like it's an opportunity for you to create a digital environment for some of your activities. Right? So, if at a minimum you're just using it for a slideshow, that's fine too. But it's free, so why not? Let me just show you one of mine real quick. It's for an upper level. I'll take some time this week, and I'll do a project too. So I'll do a Unit 1 assessment also, so that you can see kind of where my brain takes me. But let me just go to collections. I got a nice geometry one here. So I created a triangle similarity. It's pretty basic, but here are my slides, and the idea, I'll just pop you onto one of them. So this was one of the slides where it's like just drag and drop. The whole idea being like we want to get the 2 ball into the corner pocket. So I constructed this using all the tools that were built there. I put a rectangle in, I made a billiard board, I colored in the appropriate color, but I can slide this around. I want this to get in the corner pocket. So I basically want to line up the 2. So the 2 is right here. I want to line it up, and I want to be able to miss that 8 ball. So, I start playing around with it. Maybe I want to get this going up in this direction. And some possibilities. Now, there was some math that comes into play here, but that's not really important for what we're talking about. But the idea is that I can make this manipulative and allow the students to play around with it. And then it doesn't even have to be something that I grade on accuracy. I grade it based on whether or not they bothered to do it. Did they spend the time to do it? All right, cool. Now that you did it, what did we learn from it? Let's look at all of our diagrams together and do a quick comparison, right? Johnny came up with this diagram. What do we think about that? What do we think about Tony's diagram? What do we think about Javi's diagram? Like all these different possibilities. And eventually we kind of flesh out what or we don't have to flesh out what the learning objectives were, but we flesh out a good response to the learning objectives, as in, like, what's the rule? Like what is it that we're, what are we supposed to learn from this? By looking at all the students' work, we say, okay, that one's going to work. That one's not going to make it into the corner pocket. That one isn't. What are the ones that are going to make it have in common? What are the ones that are not going to make it have in common? And voila, you have learned everything that you were supposed to learn in the lesson without me ever giving you the rule that these 2 angles need to be the same and these 2 angles have to be the same, right? The students give that to you. So it's pretty cool stuff. There is a learning curve with any form of technology. There's always a learning curve, but that's just an example. If you don't like this, then don't use it. But if you do like it and you have questions, ask them. I can definitely help. All right. So again, not a requirement. If you had a thought about handing students out like napkins or something like that as part of your activity, or little shapes or something along those lines, those are perfectly fine. You don't need to do it using technology. It's just I wanted to give you another resource. All right. So I'm going to stop this recording.